Hello all, welcome to Cloud Technologies. So as part of our AWS and MuleSoft course, today we will be discussing about a couple of AWS services which we are going to use, the major AWS services which we are going to use very frequently in our day-to-day projects. Alright, so actually we have created AWS account in last video and we have discussed about all the basic topics and all the AWS terminologies in previous videos. So if you are watching this video for the first time, I would like to ask you to watch all the previous 3 videos, and while creating the account also I have created another video. So please watch all the previous videos in this particular playlist so that you can come back here. It will be really helpful for you to understand little bit terminologies. Okay, so in this video, actually we have created the account in previous account itself. We can start with creating a new service and we can discuss about all the services and all one by one. But before that, at least we should have some idea about what are the different services available in AWS, what are the different categories of services available in AWS, so that based on our requirement, based on our context, in our project, we can select the particular service from the AWS and we can utilize it. That will give you some overview about all the services, and that will give you some sense like which service when we can use and all. Okay, so that is why I have created this video. I will explain this with a real-time project example. I will just take one example in real time how we can build a project under a simple example, so that you can at least understand which service will fit into which scenario. I have already covered this in Telugu language and we published it already. So if you are looking for only Telugu language video, you can watch that video because I have explained everything in Telugu there, so that it will be easy for you for the Telugu students. But I am just creating this video in generic English, so that everyone can everyone get some help out of this video. Okay, so without wasting time, we can just start it. So I will take just an example and then I will tell you one by one. So in our example, we are going to create a social media kind of application. Like we have this Instagram, WhatsApp, Facebook, Twitter, and in previous days we have the Orkut, Yahoo, all the messaging engines and all, right? So we have this kind of social media applications. So in our example, we want to implement similar type of social media application which is related to our CLAT, which is clatbot.com. Okay, just similar to, maybe you can just correlate this with Twitter or Facebook or Instagram, anything, and we will discuss everything in detail. So our motto is to build this social media application. So to build that, what are the different steps we have to follow as a developers, and for the end users how this will help, like that we will discuss one by one. So let's assume that we have already implemented the code for this clatbot.com, because the code part we will discuss at the end of the video. What are the services available in the AWS to develop the code and all. Okay, so to maintain the code and all. So let's first assume that at this moment we have already developed the code, then we have tested it in locally. Now we want to deploy this application. We want to deploy our application into a server so that everyone can use your application and everyone can use your application. Register into your application. Everyone can utilize your application. The end users. So to make that possible, we have already discussed in our very first video what is a server and what is the why need of server and all. So we have to deploy our application into a server to make it available to everyone. So to do that, we have at least first step we need to do is, first we need to have some private network, right? So to make our environment secure, to make our servers secure, our data secure, first thing we need to have a private network. So let's assume that we have this private network. We have built some network connectivity. And remember one thing, this is without AWS. The first part which we are going to discuss now is without AWS. So if AWS is not there, any cloud service provider is not there, how we are going to implement this application? It is nothing but on-premise application. So in our on-premise application, how we are going to maintain our infrastructure, how we are going to do connectivity with one component and another component, that we will discuss now. Once you understand this scenario in on-premise, then we will discuss about how we can implement the same application by using AWS services, so that you will get complete end-to-end idea. So in on-premise, we have just built our own private network. Then to deploy this cloud.application, like to deploy this code into a server, we need one server, which is web server. Sometimes, I mean, usually we will call it as web server, and I just named it as virtual machine, but usually it is a server. So first thing, we need to have a server, and inside that server we have a disk, some internal disk. In our laptops also we have some hard disk, right? 512 GB SSD. Nowadays for every laptop is coming with SSD instead of HDD. So let's assume that this is a 512 GB SSD or maybe 256 SSD, something like that. It's an internal storage, what I want to say. So one server we have, internal storage we have. So we have deployed our application here in this web server, right? Then how the users will connect to this server? Every server will have an IP address. Once we have any server, even in our laptop also, like in the network, network point of view, even for our laptop also, we have an IP address. If you just go to Google and type for what is my global IP address, or even in a command prompt, if you can give for ipconfig, if you run that command, it will show you the IP address of your system, which is local for you and which is global for you when you search in Google what is global IP address, right? So through that IP address, we are actually going to connect to the server in general. Every server which is which is running in a network, it has its own IP address. IP address is unique, that you might already know about it. So through IP addresses, these end users are going to connect to this server and they are going to use my application. So this is first step. Then, okay, I have built my application, I have deployed it, users are using it. It is a simple one, right? So next, what I want to do, I want to increase my application, like I want to extend my application further by adding more functionalities. Like let's say this is the social media application, right? So I want to implement a feature called charts, to chat with my friends, and I want to add some feature like to add the friends and to add it to groups to create the communities, like that. So even in WhatsApp also, recently they have provided a lot of updates to create the channels, to create the communities, and all. These are all recent upgrades for the WhatsApp, right? So just like that, I want to upgrade my application to add some more features. So in that scenario, only web server cannot handle that much code. So we need to have an application server, another server which will handle this business logic. So in this application server, we will be going to write a business logic and these login pages and all the stuff. We can write it here. Just like a model view controller MVC architecture, you can assume in that way if you are aware of it. Okay. So I have a need of application server here to have all the business logic. And this server is also having an internal storage. And once I have done with all these things, I need to store my data in a database, right? Because if let's assume that here at this stage I have 100 to 200 users who are going to utilizing my application. Let's assume that 200 users are using my application. So all the 200 users related data, login data, their credentials, their information, their contact information, everything, I need to store it somewhere, right? So to do that, I need a database. I need one relational database. Okay. So in this database, I am going to store all the data, and then this is called, in general, this is called 3-tier architecture. It is very simple one, but just assume that it's a 3-tier architecture, like model, view, controller kind of architecture. So far it is good. It's a very simple application. I have extended something, and I have one web server, application server, and to store my data, I have some relational database, right? So now, going forward, like let's assume that my users are 200 users as of now, right? So now my application is going to be a huge hit, and a lot of users are going to using my application. Okay, so let's assume that 1000 users. Now my users are increased to 10,000, to 20,000, 30,000. Because if you can take the WhatsApp or Instagram or Facebook example, there are millions of users. So let's assume that my end users are increased, and they are 20,000 users are using my application. So that much load one single server cannot handle. That is why we have extended our architecture by adding another web server, another application server, and this server data also storing into this database. So we have extended our application, which is nothing but scaling. We have already discussed about horizontal scaling and vertical scaling. So now in our application, we have scaled our application horizontally by adding another servers. Okay. Usually, we already discussed about vertical and horizontal scaling, so I don't want to repeat to waste the time. So please watch our previous videos; you will get better idea. So now we have extended our application, sorry, our architecture by scaling horizontally by adding another servers. So whenever you have two servers, two different servers have two different IP addresses, right? So when my user, before that, I have two different servers, and I need one thing called load balancer. We have already discussed about load balancing also. So because like for 10,000 requests or 50,000 requests are using my application, 25,000 requests should be handled by this application, another 25 should redirect to another server. One server is handling some, one server is handling some. So to control this mechanism, we need a load balancer. So that is also I have added here. Then whenever you have two different servers, each server has its own IP addresses. So how these users will connect to this server or this server? They need to have two IP addresses with them, right? So they can again use same IP address. So the again in single server itself the load is increased, right? So to avoid that, we need to have a dynamic mechanism, some kind of dynamic mechanism, like users doesn't know what is the IP address. We will just give this domain name only for the users. So whenever user hit this clatbot.com, internally my load balancer will check load, and it will distribute that load to this server IP address. Few requests it will distribute here, few requests it will distribute here. So end users doesn't know what is the IP address. So to have that functionality, we need to have a DNS, domain naming service. So we need to add that configuration also to make this available. I mean, to users can use through our web domain name, our website name, or domain name. Instead of accessing with IP address, users can just click on clatbot.com. Load balancer will redirect to the any of the IP address based on the load. So far it is clear. So whenever my users are getting increased, data is also getting increased, right? When I to handle 100 users, it is easy, but we have now 20,000 users. How can we handle that much large data? And relational database itself is not sufficient to store that much large data. So in this situation, we need to have another kind of database, which is NoSQL database. So here maybe some data we can store it here, some relational data we can store it here, other data we can store it here, we can split the data. So now the load on this database will reduce little bit. Even though we stored it in two different databases, we will be having one issue, like let's 10,000 users are going to use the same request again and again. Every time database will hit, the data will come back. Every time 10,000 times we need to call the data. So to avoid that, we can implement one cache mechanism. So we can have some cache here. So if the same user request for the same data, we can cache that data here. So if we will get the same request, we will send the response from this database cache directly. Instead of calling the database 10,000 times for the 10,000 requests, let's assume that in the 10,000 requests, 5,000 requests are repeating requests. So for that repeating same data, static data doesn't change. Like to read his profile, to log in his profile, to read his profile, to watch their friend request. So friends, I mean, some data is static data. I think you got it right. So for the static data, we don't need to hit the database every time. So in the 10,000 request, maybe for 5,000 request, it is static data. For that 5,000, we will send the we will store that data here, the response here, and we will send the response back to the users from the DB cache itself to avoid the multiple database calls. So in this way, we can reduce the load on the database and we can improve the performance also. So we have this cache mechanism at this stage. So far we have extended our application little bit. We started with only one web server, but now we have extended our architecture to facilitate more number of users and to improve little features. So now, what will happen in social media applications? Like they will, these many 10,000, 20,000 users will upload multiple number of photos, multiple number of videos, right? We have lot of photos and videos data, which is not which the internal storage cannot handle. So this is a, like for example, maybe 20 GB hard disk you have. The photos, videos uploaded by this 10,000 users, 20,000 users is exceeded of 20 GB. It has 500 GB data we have, for example. I mean, this 10,000 users uploaded 500 GB data, which is not which cannot handle by this internal storage. In that situation, we need to have some external storage. Like in our laptops also, we are not going to store everything. We will be having some external hard disk, or we are going to handle this. I mean, we are going to store this in Google Drive or OneDrive, like that, right? Those are all the external storages. So we need to have some external storages. So here, this symbol you can see, this is a external storage. So we need to have this external storage to store our large data. That is one thing. And another thing is, some people maybe intentionally or accidentally, they can upload unnecessary data or unwanted data, like some nudity pictures or some other some like what is that, some unwanted data which is not useful for everyone and which is a harmful, right? So to avoid that, we need to have some mechanism called content filter. We need to filter that content, whatever the content users are going to upload. Before storing it into the external storage, we need to do some filter mechanism. If the photos or videos or whatever the uh, data they are uploading, if it is follows all the compliances and all the guidelines and all the rules, then only we will upload the data into the external storage. Otherwise, we will not store. Like that, we need to have some filter mechanism, right? Then if you remember, we need to analyze this data actually. But if you remember, when you logged in into the social media platforms or any other website, it will show you some ads here in your page, right? But those ads are relevant to your search, which means if you are maybe if you are searching for in an Amazon also, if you are searching for some handbags, or if you are searching for some electronic devices, the ads related to the handbags, the ads related to the electrical devices only posted in your web page. So if you log in into the Facebook, or if you log in into any Instagram or any other web page, you will see couple of ads which are related to your interests. How the server or how that application will know your interests? See, if you are searching for handbags, or if you are searching for only mobile phones, if the ads is showing some kind of books or some kind of movies related stuff, you will not interest in that particular ads. You will not click that ads in general, right? If you are searching for one handbag in Amazon, then you just go to the Facebook, you are searching something. If you some ads come up with like we have this latest collection of handbags, then obviously, as you are searching for the handbags and all, so obviously you will click on that ad and you will do some purchase and all that is beneficial to the vendor. So like that, this is just an example, but like that, we need to analyze the data. See, all these things are it is doing in the background. The end users doesn't know what is happening in the background. That you need to remember. As a developer or as a team of infrastructure team or developer team, we need to make sure to design our architecture. We need to consider all these points. Okay. We need to consider all these points as a developer, but the end user doesn't know, so that keep in mind. So we need to analyze the data. What are the different users, what is the age of different users, and what time which users are available, and what is their interests, what is their mood, what kind of post they are seeing in regular way, what kind of products they are using, like that. All the information, once the user clicks on this, so all the clicks we can capture here, and we can analyze those clicks. So based on that clicks, or based on their interest, based on the data they are searching, we will do some analysis. It will helpful for us to improve our application little more better in the future. So based on their interest, we can implement our application, so that is again attracted to the end users. Our business also will grow. So to analyze that data, and we have that analysis to analyze the data, then we need to store that data also into an external storage, just like this. And then to do some operations on top of that data, we need to have big data kind of systems like Hadoop or big data or some other tools are also there. So we need to have that kind of service here to do some query operations or to sort the data or to do some manipulations on the data, to do some other operations on the data. We need to have some big data kind of stuff here. So then we will store this data into some kind of data warehouse system. Once we process the data, we can organize the data in such a way and we can store that into a data warehouse. Then from here, some kind of business intelligence tool will take. We have business intelligence tools like Power BI and other Tableau, something other tools also there. Na? What they will do, they will just analyze the data and they will get the data, the structured data which we have stored in our data warehouse. They will take that data and they will generate some reports, and out of that reports, it will be useful for the business to improve their application. So all these things are doing in the background. So let's say this is our architecture now. For example, now few users, what they can do, they can directly call to the sectional storage. For example, in our example, Google Drive or OneDrive, they will access the application directly through web application, and they will play the data there itself. For example, in Google Drive, okay, we are not going to download the photo, download the video every time if we want to watch. We'll just play the video there itself instead of downloading. So in the external storage itself, we are directly playing the videos, or we are directly accessing it. So to do that, few users are using web application to access that, and a few users are using mobile application. But nowadays most of the users are using mobile only. So even few users connected through mobile, and they will connect to the external storage to access the photos, videos, and all directly. So to do that, we need to implement some kind of mechanism, like a few videos are supported by laptop or supported by tablet. Few video formats are supported by mobile application, because in mobile we have this Android and iOS operating systems also, right? So few will connect to the couple of extensions. A few videos will play in mobile, few videos will play few versions, okay, in a web application. So to do that, we need to do some convert mechanism. See, for example, in laptop we can play MP4 videos, but in mobile we can play the same video, but the extension should be AWI or AVI, sorry, AVI format. Let's assume that mobile will support AVI and web application will support MP4. So what we need to do, we need to convert the MP4 video to a AVI format, and we can store in this sectional storage. This sectional storage is specific to mobile users. This sectional storage is specific to web application users. So that once they hit the application, they can use that and they can play that videos and all. Right? So this is how we need to manage. And sometimes, let's say a few videos or a few photos or few YouTube videos are going viral sometimes, right? So even in that case, like millions of users will use the same, will want to see the same viral video. So in that case, every time if you would like to to control this, just like the database calls. So if let's say any video goes viral in YouTube, most of the users are hitting that same URL link, same YouTube link, right? So again, the data is static. So every time if they want to connect to the database, connect to this external storage, it will be little costly. So to avoid that, we need to have one mechanism called content delivery network. This is also a kind of cache. Okay, just like we discussed here, this is also a kind of cache. So any frequently requested data, we can store it here, and mobile users can connect while they are trying to access the sectional storage. Instead of sending the data from the sectional storage, we can send the videos, or we can play the video, we can show the photo from this CDN. So this will improve the performance, and this will reduce the calls to the external storage, right? Like, so let's assume that this is our infrastructure and we are done with this infrastructure. Now to additionally, we need to have some more features. We need to provide some more features to our application. Let's say if any friend request is there, or if any new feature, any post is there, any any comment on your post in general, you will get SMS or notification, right? Like someone liked your post, someone commented your post, someone mentioned your name in that comment, like that you will get some notifications, right? So we need to implement that feature also in our social media application. We need to implement that feature also in our clarkbot.com. So to do that, we need to have some mechanism called SMS or notification. We need to implement that. And sometimes whenever any friend request accepted or anything happened to your account, you will get emails also. So we need to implement email service also. Apart from that, to chat, to discuss with your friends or to chat with your friends, you need to have a message queue mechanism. Because see, for example, if I send a message to my friend like, hi, how are you, what are you doing, these are the three messages. First one is hi, then how are you, then what are you doing. So when I type hi here, and maybe let's assume that I have typed all the three messages one by one, which is not delivered to my friend because my friend mobile data is switched off. Mobile data is off, so he doesn't receive my messages. So those messages will be stored in my queue. Once my friend open the network, I mean once my friend switch on the Wi-Fi or on that mobile data, these messages should deliver to my friend. What is the order we need? Those messages should be delivered in the same order. Like I have sent three messages, hi, how are you, what are you doing, these three are not delivered to my friend due to some network problem or something. So once their network problem is resolved, these messages should be sent to my friend in the same order. My friend will see the order like, hi, how are you, what are you doing. He don't, I mean, messages should not be clubbed, or messages should not miss the order. If he can see the first message as what are you doing and second message as the hi, like that, it should not happen. Whatever the order we are sending, that same order the message should be delivered to my friend. So to have that, we need to have message queue mechanism, because in this queue we have a feature called FIFO, first in first out service. So by using that service, we can maintain this order, right? So these are all the minimum requirements, these are all the very basic requirements, because in our social media, in Facebook or Instagram or WhatsApp, they have a lot of infrastructure. This is just a basic structure. Okay, so to build this basic structure, we in on premise we have to do all these things by our own. We have to do this load balancer, we have to procure these servers, we have to procure these external storages, we have to get these databases also. All these things we have to do by our own. This is a huge investment. Okay, to avoid that, cloud service providers are providing all these things as a services. To create the server, they have a service. To have this external storage, there is a service in AWS or Azure or GCP. So all these cloud providers will be providing all these requirements in form of services. So now let's see with the AWS how we can achieve our requirement, how we can achieve our I mean infrastructure, how we can build our infrastructure by using AWS services. So in our next slides we will see that. Yeah, I forgot one more thing. Once we're done with this all this application implementation and all, at least for this infrastructure, at least we need to monitor it. Because some kind of ETL, by using use of some kind of ETL tools, we need to get the data, we need to monitor our application, how my VMs are performing, how the storage is performing, if storage limits are going down for particular times, or if cache is not working fine, if this Hadoop is not working fine. So to what are the how the messages are sending, is there any blockers or is there any performance issues. So to analyze all these things, we need to monitor our application every time. So to do that, we need to have some monitoring feature also, and some ETL kind of feature also in our application. So we have different services for this monitoring and ETL also in AWS. So we can see those as well. Okay, so once this monitoring is done, like once this server is getting much load, we will send some notification to the customer, like that. Some notifications, alerts are also we can implement here in this monitoring feature. Okay, so now let's see how we can implement the same clarkbot.com in AWS by using lot of AWS services. We will see that one by one. Yeah, so let's see what are the different services available in AWS. First we have started with our private network, right? So in AWS, to create this private network, we have a service called VPC, Virtual Private Cloud. So by using this service, we can generate this private network. Okay, so then I have removed all the VM machines here from our previous image, right? So in EWS or in AWS in Amazon, we have virtual, to create these virtual machines or to create these servers, we have a service called EC2. So by using this EC2 service, we can create the servers. Just we have discussed this in our hypervisor and virtualization topic, right? So to create virtual machines, there will be a one physical server. In that physical server, we'll be creating a virtual machines, virtual servers, right? So to create that, we have this service called EC2 service in AWS. And along with that, we have some internal storage, right? We have discussed some storage here. So to have that storage in AWS, we have the service called EBS service. By using this service, we can create this storage here, internal storage, right? And to scale these applications, okay, so to scale the servers, sorry, not the application, to scale the servers, or scale up or scale down the servers, because in our example we have seen we have started with one virtual machine in without AWS also. Then once the load is increased, we have extended our architecture by horizontally scaling our infrastructure by adding more servers, right? So to do that, instead of doing it manually, if we are thinking, I mean, if you are thinking like if we can do it manually, it will take much time, right? If we can take this do this manually, it will take much time, and we need to have some manpower also. Instead of that, in AWS we have auto scaling. We have a feature, or we have a service called auto scaling. Once we configure this auto scaling, it will take care of the scaling. So if a load is increased, it will add more servers, or it will create more virtual machines. If the load is decreased, it will remove the existing virtual machines, and it will send the load to the single server only, like that. Based on the situation, based on the load, it will automatically scale the infrastructure. So for that, in AWS we have auto scaling. And then for load balancing, yeah, let's discuss that load balancer later. So to store this data, we need to have some database, right? In our previous architecture in on-premise, so in AWS we have a service called RDS. RDS is the service by using which we can create the database connectivities like SQL or Oracle or any other relational database. So that is why it is called RDS, relational database services, right? Next one, for this NoSQL databases, we have a service called DynamoDB in AWS. By using this DynamoDB service, we can use this NoSQL databases features also. We can store the data. So to have this database cache in AWS, we have Elasticache is the service. So we have already discussed what is the use of cache here. So to implement that in AWS, we have Elasticache. We can use that service. And then for this load balancing, in AWS we have ELB, Elastic Load Balancer. That is the service available in AWS, Elastic Load Balancer. We can use that service, we can configure that service here to maintain the load, or to balance the load between multiple virtual machines. So for the DNS feature in AWS, we have Route 53. Route 53 will dynamically map the domain names to your application, and it will route that. Okay, so Route 53 is the service which we are going to use as a domain naming service to our architecture, right? Next one, to store these photos, videos, or media or anything in the external storage, we have discussed earlier, like we have that okay, we have that Google Drive, OneDrive and all, right? So in AWS we have one service called S3 bucket, simple storage service. In AWS we have a service called S3, which is useful as a external service, and there is no limitation. So we can store any large number of data here, because this internal storage or this EBS have some limitations. We cannot exceed that. But in external storage like this simple storage service or this S3 service of AWS, we have no limitations to store the data. It is a large data store, we can use it, the storage one. Okay. So to filter this content, we already discussed like we want to filter unwanted content. We have a service called recognition in AWS. So by using this service, by configuring this service, we can filter the content. Right? Next. So to convert this, so for mobile users, for web users, there should be a different formats of videos and all, right? So to convert this, we have a service called Lambda. Lambda is a kind of function, Lambda service. This is also a compute service, which means so we can do this in two ways. Like we can have one more virtual machine, and we can store all the data. We can download the videos from this. Like for example, we can download MP4 video into another virtual machine. We can do the conversion code there. We can convert that video to AVI format, and then we can upload that into the another storage, which is related to the mobile S3 bucket. We can do in that way. But instead of having the server, instead of writing the code inside the server, instead of deploy that application to do all this stuff, to avoid that, we have a simple feature or simple service called simple service is available in AWS, which is called Lambda function. By using this service, we can write some code and we can write some functions to convert this MP4 video to AVI video format. It will take care of it. Okay, so this function will run every time whenever any photos or videos are uploaded into this storage. This function will run. This will convert that, and it will store that converted files here in this mobile S3 storage. So Lambda function is useful whenever you want to implement a single task. Whenever if you want to achieve a single task, you can use the Lambda functions instead of EC2 missions. So we can use these two are the compute functions available, and we have lot of services also. But in our scenario, we can go with Lambda function here to do simple task. Instead of this is called serverless computing, so we no need to create a server. We can no need to deploy application into the server. Instead of that, to avoid that, we can have kind of function mechanism which is a serverless computing. So server is not required here. You can just directly write the code to convert the format from MP4 to AVI in our example. In other projects also, if you want to achieve some functionality, you can write that functionality. You can write code for that functionality, and then you can use this function. You can make this function run every time so that it will take care of it, right? Then yeah, to do the analysis part, we discussed it, like we need to do some analysis on the data whichever the users are uploaded and all, right? So to do that in AWS, we have a service called Kinesis. By using this Kinesis, we can do the analytic stuff. Then for this big data Hadoop and all, in AWS we have EMR server, which will handle the big data analysis. And then the ETL tool which is having in our AWS to do the ETL operations, extract operations, ETL operations, we have a service called Glue. Okay. Then for this data warehouse, okay, to store the large number of data, I mean for this analytical data, for the data warehouse stuff, we have a service called Redshift. Redshift service is there in AWS, which will be used as a data warehouse, right? Then for the business intelligence, like to take the data from this data warehouse to generate the reports, to do some business intelligence stuff, in AWS we have a lot of services, but primarily we can use Athena service or QuickSight service. Majorly we are going to use these kind of services for business intelligence, because for computing also we have EC2, Lambda and other services also. In our scenario we are using EC2 Lambda, right? So just like that, to do the business intelligence stuff, to generate the reports and all, we can use any of these business intelligence service. One is Athena, one is QuickSight, and we have another services also. Then for this content delivery network, right, to catch the data, to catch the viral data which we have discussed earlier, to do the data catching here at this stage, in the network stage, we have CloudFront service. In AWS, we have CloudFront service. By using that, we can do the content delivery. Content delivery network feature we can implement by using CloudFront service. And what is this edge locations here? So the service which we are going to use is CloudFront, but there is a concept in AWS called edge location. Edge location means which is a cache location. So whatever the data is frequently accessed by this particular service or by this particular region, because edge locations, we have multiple edge locations in a single region. We can have multiple edge locations in a data center. All right. So why? Because a lot of services are having very frequently accessed data. We can cache that data here in the nearby edge location. So very nearby to that region, we can create it. AWS is not we. AWS is having edge locations, so they can send the data from the edge location to the user. They can cache the data. They can send that cache data to the end users from this edge location instead of getting this sending to the from the external storage of the particular region. So this is a edge location is a concept in AWS. They can cache the data through the network, and they can improve the performance, and they can improve the latency also. Sorry, they can reduce the latency also. Okay, so CloudFront is the service to configure this content data networks thing. Then we have discussed 3 more features here, right? To send the SMS or to send the notifications, we have SNS service in AWS. This is simple notification service. By using this service, we can send the SMSs or notifications. And to send the email notifications, we have a service called SES, simple email service in AWS. We can use this. And for the queuing mechanism, which we have discussed earlier, first in first out something, we have a AWS specific queue, which is simple queue service, SQS, which is nothing but simple queue service, which is available in AWS. We can use that. Right. So far we have seen lot of services in AWS, right? So for monitoring data, to generate some dashboards and all, we have a service called CloudWatch. By using this CloudWatch service, we can monitor our data, monitor our servers and all. We can do all the monitoring stuff, and even we can generate some kind of alerts also. If storage is increased, or if EC2 server is down, if any server is down, any server is having a lot of load, something. Based on different scenarios, we can configure the alerts, and by using this CloudWatch, we can do the monitoring stuff as well as alert stuff also. So in our simple to implement our simple social media platform, to implement this cloudport.com, we have these many features, we have these many requirements, and AWS is supporting each and everything. If you can see, each and every requirement, to achieve each and every requirement in our infrastructure, AWS is having services, lot of services here. So we have seen lot of core services here. So only thing is in an on-premise system without AWS, we have to do all these things. Like we have to implement code for everything, right? We have to write a code for SNS. We have to write a code to create the server. We have to write. We have to procure these external storages. We have to procure the databases, everything, which is taking most time for the lot of the time developers to write the code, and which is very expensive. To get the storages, or to get the databases and all, to get the servers also, it is very huge investment in on-premise. But in AWS, see, we have lot of services for each and every requirement. If we have a lot of requirements here, each and every requirement, we have specific service in AWS. So if you want to use Lambda service, you can procure Lambda service here in AWS. So if you use this service for 1 hour, you can just pay the rent for that 1 hour only. Or for example, you can just take this S3 bucket, external storage service. If you are taking this for 1 month, only you have to pay amount for that 1 month only. You no need to pay for the lifetime. Maybe for example, for after some days, after a few days or after few months, your application is not hit. Your application is going down. Some other competitor is coming to the market. So in that case, you will not get much load, or you no need this much servers. So in that case, you can just simply terminate these EC2 instances. We can simply terminate these VMs, virtual machines. You no need to pay for these machines. You can that is what, like, pay as you use. That is the main motto of all these cloud service providers. Even if AWS, Azure or GCP, you can pay whatever you use. So till what time you have used. If you use it for 1 month, if you use it for 1 hour, if you use it for 1 second, you need to pay for that 1 second only, not for the 1 hour also. So that is the model called pay as you use. So we have seen couple of services, like based on our requirement you can use that service, you can pay for that service at the end of the month, right? Now let's see some other things. Yeah, now let's see a few more services in AWS. Okay, so to work with any REST services, or to have more routing services, you can have API gateway. If you are going to use REST APIs kind of stuff, there is a service called API gateway in AWS. So which will be configured between this Route 53 and ELB, Elastic Load Balancer. Between these two, we can configure this API gateway. We can utilize the REST API calls and all, and we can configure accordingly based on the throttling or any other policies we can implement over there. So we'll discuss this in depth in detail going forward. Okay, so another service is like Cognito. By using this service, you can maintain the user pools, you can manage the user pools. Like from a web application we have multiple users, from users from mobile application we are getting multiple users, right? So once they registered, we need to secure their information, we need to make sure their credentials are secured, we need to make sure that user remaining data is secure, right? So maintain these user pools and all, we can have a service, we have a service called Cognito in AWS. By using this service, we can utilize, we can use this user pools, right? So apart from this, we have another services which are called security services, which is very important for even if any organization or if any application. So every application which we are going to build should be very secure. So the data should not be mishandled, or data should not be hacked by any other third-party personalities, or data should be data should be more secured. So to have this our calls should be very secured, and our application, entire our infrastructure should be in secure mode. So to do that, we have a couple of services in AWS. Let's discuss one by one. So the first one is IAM service, which is the very first service. Whenever we want to learn AWS, everyone will start with IAM service only. Even we also going to discuss the IAM service for the first one. So what is the use of IAM services? It will be useful for the access, authentication and authorization for the users. So to create the user, to provide access to that users, to authenticate the users, and to provide authorization to the users for the different services. We will discuss about the authentication, authorization in depth when we discuss about IAM service. So to maintain these users, accesses, authorizations, authentication, user credentials stuff, we are going to use IAM service in AWS. IAM means Identity and Access Management. So another one is KMS, Key Management System. So let's say for example, we have a lot of data transfer here. In the servers also we have some data, and in database we have some data. In this warehouse we have some data, the photos, videos, everything, all the media related data we have there in this sectional storage, and this analytics data is there here, and our chart messages are there here. So we have a lot of data interactions in our application. We need to make sure our data is secured. While traveling through the network, while traveling through the internet, the data should be secured. Our data should be encrypted and decrypted. Let's say for example, even in WhatsApp also, you can see if you open any new chart, there will be a message. End-to-end encryption is enabled for this chart, and something like that. So you will see some kind of pop-up like that. End-to-end encryption is there for these messages. So which means end-to-end encryptions means once we send the data here, once we, let's say for example in our previous example also, I said like I sent hi as a message to my friend. So once I type the hi and click the enter, that message is traveled through the network, traveled through the internet, and then that hi message is delivered to my friend. Right? So hi is a simple message. If anyone hack it, or if anyone take that hi message also, they cannot do anything. Any hackers also cannot do anything with that simple hi message. Let's say for example I am sending my bank details to my friend. So maybe she needs some help or she needs some information. I'm sharing my personal information, my Aadhaar card number or my OTP. Usually we will not share this through messages, but just let's assume that. Let's say I'm sending my bank details, my account number, my FC code, or my username, net banking credentials, username, password. Maybe my relative or maybe my parents need that in order to log in and in order to transfer some money. Maybe my parents need my username and credentials, username and password of my net banking, for example. So I'm sending that data in my message. I'm sending my username and password. So while traveling through this network, anyone can hack that data. So when I enter my username and password, when I click enter, it will travel through the network to my parents' mobile. Right? Through this network, anyone can hack the data, anyone can misuse the data. If anyone can take that username and password through the network, they can log in into my account and they can grab my money, right? So to avoid that, we need to implement the encryption mechanism for our data, which is traveled through the network. So when I entered my bank details in my mobile, when I entered my username and password, when I hit enter, then my data should be encrypted. Before traveling through the network, my data should be encrypted. Encrypted means it should be locked, and instead of the original username and password, it will show some encrypted message like for name, numbers and letters, which will be understood by the keys only. We will discuss this encryption in detail going forward. If you want to see that, we have already another video in our channel related to MuleSoft. We have this HTTPS SSL mechanism, HTTPS SSL series. We have 3 videos are there. You can watch those videos, you will get more idea. But for now, just assume that my username and password, once I enter here in my, once I hit enter button in my mobile, it should be encrypted, it should be locked. And through the network, till that data is delivered to my parents' mobile, the data should not be unlocked. That original username password should not be visible in the network. So if someone hacked that locked data, like encrypted data, they will not understand what is the original username and password, because the original username and password will not be shown in that through the network until unless it is delivered to my parents' mobile. So once it is delivered to my parent mobile, before delivering that mobile, the data should be unlocked. I mean, the encrypted some some random data is not there. It should not be there. And before deliver that message to my parents, it should be unlocked and it will show the original username and password in my parents' mobile. Right? That is called decryption. To unlock the data, it is called decryption. So once I hit enter in my mobile, my data should be encrypted and travel through the network. And before delivering it to my parents' mobile, it should be decrypted and it will show the original message to my parents. So no one can hack the message. So to implement that encryption decryption mechanism, we have a service called KMS in AWS, Key Management System. So by using this, see, we can have encryption, we can generate encryption keys here wherever the data is there. So in this server, in this storage, we have data in all the EBS storages, and cache also we have data. In databases we have some data, in SQS we have some data. So wherever the data is there, we are going to encrypt that by using this service. Another one is ACM. I think it is application certification management. If I am wrong, I will correct it later in the upcoming videos. We have a service called ACM service. By using this, we can generate the secured certificates. See, for any website, if you can see https.cloudcode.com, then only that website is the secured one, and we can trust that website. Some websites are called only HTTP. There is no S in the URL. So those websites are not secured. If you are doing any payment transactions, if you are doing anything in those HTTP networks which is not secured, and anything happen to your data, anything happen to your username credentials, and that your data or your money is misused. So we need to make sure all the services are HTTPS services, which is secured services. And to make that service secure, to make that one secured, we have some certificates called SSL certificates. So to generate those certificates, to add those certificates, we have this ACM server. service. So what this service will do, it will generate the certificates, secured certificates. It will add those certificates to CloudFront. We will in our infrastructure we will add these certificates to these two places, CloudFront and Elastic Load Balancer. Here we will add those certificates through this through this ACM service. Then we have another secured service called WAF, Web Application Firewall, to avoid some attacks or to avoid some hackers. Like if some random person or some hacker will access our application, this firewall will reject that requests. It will reject those requests. So we have this firewall setup to reject some IP addresses or to unblock their IP addresses and all, to avoid the to avoid those users to access our data. Okay, so we should be implemented this web application firewall also, which we can configure on top of ELB or on top of CloudFront. Another one is Inspector. There is a service called Inspector in AWS. What it can do is, it will be like a antivirus in our laptops. Just assume that. So if there is any malwares or if there is any vulnerabilities, it will scan that, all the servers data, it will scan that, it will send a notification, or it will remove those viruses and all, like that, whatever the way we configured. But the main thing is, use of this Inspector service is to scan our service servers, and to find any virus or vulnerabilities are there, it will notify the users. Okay, so that is those are all the security services. Apart from that, we have a couple of services which are related to the developers or DevOps teams. So let's say, if you remember, in the first part of our video, we assumed that this clapboard.application code is already developed. So we have the code and all, we have discussed it. So once we developed the code, we should be store the code somewhere, then only that code should be deployed into this server. Right, so we will see development tools or development services or any DevOps services which are available in AWS. So before that, we will see one thing. So to implement this infrastructure, or to create this kind of infrastructure every time for this one application, it is taking 2 to 3 hours or maybe one day if you are new to this. To create these servers, to map these servers, because all these servers are interconnected to one another. If you see, right, this EC2 is connected to this storage, this edge location is connected. All the services are connected to one another. So to create all these services manually, to map this one to another service, to map these services one to another, it will take much time. Okay, so to do this manually, it will take much time, but we can do it automatically also in AWS. So we can configure all this setup as in part of a template, just like a JSON file or YAML file. We will add all this configuration and we will write all these things in a JSON or YAML file. We can put it there, and there is a service called CloudFormation. Okay, this will create this complete infrastructure for us by using JSON file or YAML file within seconds or within minutes. Maybe within 30 minutes it will create this infrastructure for you. It will give it to you. That service is called CloudFormation, to create the infrastructure automatically. But it is based on the JSON or YAML file which we have provided. Let's assume that there is a developers, and in every project we have 3 different kinds of developers: normal code developers, development team, and testers, the testing team, QA testing team, and DevOps team to maintain this code pipelines and all. Okay, so let's assume that this DevOps team implemented the code for this write a template code. They already wrote the template code for this infrastructure, and where they can kept this template code, there is a service called CodeCommit. It is just like a Git version control system. If you are aware of Git, then it is easy for you to correlate. So just like the Git service, the version control system, in AWS we have a CodeCommit service which is useful for developers as well as DevOps team to commit their code, to keep their code into version control system. So let's assume that this DevOps team write the code for this infrastructure using a JSON or YAML file. They created the template and they have committed the template here in the code commit. I mean, they they kept this in the version control system. This is the template. So what this CloudFormation will do, this CloudFormation will take this template from here and it will build this infrastructure for you. So CodeCommit is the service which is just like a Git service or any other version control system where we can store the code, all the developers, QAs or DevOps. Then once we write the code, once we commit the code, before that, this is called the infrastructure as a code. This complete scenario which we have discussed, which is called infrastructure as a code. So this complete infrastructure, we have written it in a JSON or YAML file, just as a JSON code or YAML code, right? So this complete infrastructure, we have written it as a code. So that is called IAAC, infrastructure as a code. Right, so we have done with the code. So to make this code deploy to this EC2 servers or virtual machines, we need to build that code first. So to build that code, we have a service called CodeBuild in AWS. By using Ant or Maven, by using different build tools, it will build the code. It will generate the archive file. So even in MuleSoft also, we have to deploy the jar file in the Cloud Hub, right? So to jar file is called archive file there in MuleSoft. But in few systems or maybe in few other languages, we have war file, we have jar file, we have zip file, like that different kind of archive files are there. So this code build, what it will do, it will build the code by using Ant or Maven or any other build tool, it will generate the archive file. So once the archive file is available, this code deploy feature is there. It will take this archive file from here. It will deploy this application into the servers. Right, so that for that we have a service called CodeDeploy in AWS. This is CodeDeploy is a service available in AWS which will take the archive code, which is archive file, which is built by the code build service. It will take the jar file, for example, it will deploy that jar file into the servers. So to do this, we have a service called CodeDeploy. And we already heard about something, maybe few of you heard about continuous integration and continuous deployment. Right, so whenever someone commit the code, it will build automatically, it will deploy automatically. Till here it is called continuous integration, which we have already seen. So to do that continuous delivery, to build that pipelines and all, we have a service called CodePipeline in AWS. CodePipeline is a service by using which we are going to create that pipeline stuff, CI/CD stuff we can create. Usually DevOps team will do this. So as a developer, we are not worry about it, but just you as a developer or as a new learner for this AWS, you have to at least have some idea what are the different services. So pipeline service is there. So this is all about AWS development and DevOps tools. So like this, we have lot of tools available. So a lot of services, not the tools, lot of services available in AWS in each and every situation. So okay, so we will see this scope of the AWS services now. So I think you got idea about what are the different services available now. There are a lot of services, 200 plus services in AWS, but we have seen couple of services in our real-time scenario based on our requirement. We have seen couple of services. I hope now by this time you have some little idea what are the different categories of services available in AWS and how we can use those services in our infrastructure. In our example, how those services fit into one another, how those services are connected to one another. I hope by this time you have some idea. So now let's see what is the scope of this AWS services. So now, so far we have seen what are the different services available in AWS, and most of the services, like few services related to our architecture, we have covered. But you have to understand one thing. We have lot of services, 200 plus services in AWS, but few services are up to few level only. Like that, what I want to say is at a global level, we will be having few services. Global level means account level. So if you have one AWS account, at account level, this CloudFront, IAM service, Route 53 billing, all these services will be, we can use at account level, global level, which will be applicable for all the services or maybe all the users in that AWS. and few services are regional specific. So region level services are there. DynamoDB, Amazon S3, ELB, and Amazon VPC. These are few services I have mentioned here, but couple of services also there. So few services are at regional level. It means if you create DynamoDB in one region, you cannot access the same DynamoDB in another region. If you created an Amazon S3 in one region, you cannot use the same S3 bucket in another region, like that. So these are regional level services. And few services are there at AZ levels, AG levels, availability zone levels. It means in the one region we have already known 2 or 3 data centers, 2 or 3 availability zones will be there. So if you have created this EBS, EC2, VPC subnet or RDS at one AZ, one availability zone, you cannot access the same service in the other availability zone. So availability level services, these are all. So we have lot of services, but the thing you need to remember in mind, like service, all AWS services are not meant for all the levels. So few are global level services are there, few services are there like region level, and a few services are AG levels. AG or availability zone or data center, all are same. So you have to understand that, and you have to keep this in mind, right? Then, so as we have seen lot of services, and these are all the other services at different categories. For compute category, we have already seen EC2, ELB, and Lambda. Right? For storage services, we have already seen Amazon S3 and EBS. So these are all the remaining storage services. Management tool services, we have seen, what is it? CloudWatch and CloudFormation we have seen in our example. But these are all the another management tool services, remaining services. So application integration services, we have discussed about SNS and SQS in our flow, even SES. These are all the other services like that. For each and every category, we have a lot of services. We have seen couple of them in our example or in our scenario, but we have lot of other services in each and every category. Depends on our project requirement, depends on our license, basically project requirement, but depends on our requirement or our use case scenario. We will select each and every service from different categories and we'll connect them together to build a complete infrastructure to accommodate in our project. Right? So, yeah, that's about the services. Now let's discuss about high availability. We have already seen what is high availability in our previous videos. So to make our service available almost 99.5% in 100%. Okay, so we have to make sure our service is available 24/7. So most of the time our service should be available. So that is called high availability, and we have discussed it in detail in our previous videos. So to make our service highly available, or to make our infrastructure is high available, what we have to do, we have to follow a couple of things, and we have different ways to make it possible. Right, so considering different scenarios, we have to keep our infrastructure to accommodate that particular situation. Let's say if we have a data center in availability zone, in one availability zone, one data center, let's say we have a server here. What if this agent, sorry, I keep on coming AWS here, this is agent, AZ, availability zone. Okay, what if this data center goes down in this AZ1, AG1? Your application will go out, right? Your application will not work if this agent is down or this data center is down. First one, like if we have our application in only one data center or only one instance, what if this particular data center or this particular service is down for 1 hour? So in that 1 hour you cannot able to access your application, right? So to avoid that situation, we will be having two servers in two different data centers or two instances. Then we will make our service is up and running in two data centers. If one data center or one instance is down, other instance is up and running, so that our application is available. This is one scenario of high availability, and this is called multi-instance. So multiple instances we are using to keep our application up and running. So now what happened if this AG is down? The AG completely is down. this particular availability zone is completely down, you cannot access your application from this instance either or this instance. So you cannot access both of the instances. In that case, you need to assume all these scenarios while you are designing your infrastructure. Then you have to make sure all the possible ways to keep your application up and running and make it highly available. Right, so what if this AZ is down? So that is why what we can do in general is like one data center we will take it from this AZ and one data center we can take it from this AG2. It means we will implement one server here, we have one virtual machine here, we have one virtual machine here, we will deploy our application here and here as well. So two AZs. So if this complete AZ is down, this AZ is up and running. So you don't have any issue. So this kind of thing is called multi-zone, because we are having our instances in different zones, multiple zones. So it is called multi-zone. So likewise, even if we have two AZs, this complete two AZs are related to only one region, right? What if this complete region itself is down due to some natural calamities or any other things? If a complete region itself is down, we cannot access our application again. So in that, so we need to keep that in mind. So we need to create one backup or disaster recovery. This we have already discussed, right? So to keep this disaster recovery in mind, we have to have one more instance in another region as well. So that is called multi-regions. Multi-regions infrastructure is also we need to make sure. And in worst case, like in very, what is it? This will not occur very frequently, but if let's assume that if there is a scenario due to any natural calamities or anything from AWS side, maybe if something happened, if complete this cloud provider itself is down, so you cannot access your application now. In that case, we will be having one instance in one cloud provider and another instance is for another cloud provider. This is Azure. Azure is another cloud provider, cloud service provider. So we will plan in this way. That is called multi-cloud. But this will not happen in real time because it will be again a huge cost to have two service providers to have all these things. But just we have this option as well. If you want to plan your application in such a way to make it highly available, we can apply these things. We can have it multi-instance, multi-zone, multi-regions and multi-cloud as well. Okay, I hope you understand this high availability. Right, the last topic for this video is how many ways we can access AWS. Usually we have 3 different ways. So we will be discussing this in a separate video and we will be taking one example and one practical session also. I'm planning to take it because we need to understand how we can communicate to AWS in 3 different ways so that it will be easy for you in your projects. So first thing, even to create the service, to edit the service, to modify the service, to run the service or to delete the service for anything, if you want to work any operation in the service, you can access this AWS services like this S3 service or EC2 service, any of the service in 3 different ways. First one and foremost one everyone knows is console. We have already created an account in AWS console, right? So through the console we can log in and we can create a AWS service and we can work on any AWS service. That is one way. Another way is through CLI. CLI means command line interface. So through the command line also we can interact with AWS services. Okay, but there is a different ways to interact, to provide the access and all that we will be discussing in our IIM session. So third way is SDK or API calls, like HTTP service calls, to get request, post request, REST methods are there. So you can communicate to the AWS services by using those HTTP request calls or SDK or programmatically, depends on the programming language or development you are doing. So these are all the 3 different ways to communicate to the AWS services. But first thing we will be discussing in AWS console only. We have already created an account, free account, right? So we will first try to understand how to use this AWS console and how we can create services through console. Then in one of the video in our course, I would like to take one service as an example and I will explain all the 3 different ways to communicate to the same service, how we can access those services, so that you will get some idea, right? So I hope this tutorial is helpful to you, and you get some knowledge out of this video. If you really like this video, you can just please like this video and subscribe to our channel. If you have any doubt, you can just mention the timestamp and ask your questions in the comment section. I will be happy to help you. Thank you so much. Please subscribe to our channel. Thank you so much. Thanks for watching.